A very good morning, all students. In previous lecture, I have stopped in explaining various types of capacitive transducers. And in today, we are going to see the continuation of your capacitive transducer. That is nothing but the advantages of your capacitive transducer. And it has very high impedance, and therefore the loading effect will be minimum for your capacitive transducer. And it has good frequency response. Its frequency response will be up to 50 kilohertz. And it is not affected by stray magnetic field, and it is extremely sensitive device, and the resolution is of 2.5 into 10 to the power minus 3 millimeter, and the force requirement is very small, and it will require very small amount of power. And next slide gives the disadvantages of your capacitive transducer. The output impedance is very high, so measuring it is going to be very complicated, and the stray capacitance will cause error in the device, which introduce non-linearity in the output signal. And the cable is also the source of error, so this error can also be occurred due to the cable. And loss of sensitivity, also loading makes your low frequency response very poor, and the capacitance changes with the temperature change, and is also the presence of small external matter, that is dust particle and moisture, can also cause change in the value of capacitance, which affect the output. And instrumentation circuitry is make the circuit complex, that is already the circuit is little complex because of the output impedance value. The additional instrumentation circuit added to the system of transducer will make the circuit a little more complex. And coming to the applications of capacitive transducer, it is used for the measurement of linear and angular displacement, and to measure the force and pressure, and measure your pressure directly by the help of permittivity. And also the measurement of humidity is also done with the help of your capacitive transducer. Why? Because the humidity varies with the permittivity of gases, and therefore it is being used to measure the value of humidity. And it is commonly used in conjunction with the mechanical modifiers for measurement of your volume, density, liquid level, weight, etc. These are some of the applications of your capacitive transducer. And one more example for your capacitive transducer which we use in our daily life is capacitor microphone. That means the capacitor microphone is most commonly used in studios. In studios there will be a mic while singing a song or recording something, and that mic is made of nothing but your capacitor microphone, and it has a thin electrical conductive diaphragm. There will be two things present in the capacitive microphone. That is, one is your conductive diaphragm, and it is suspended over the back plate, forming a flexible capacitor. That is, there will be a movable plate. Generally, the capacitive transducer will be having a movable plate and fixed plate. Here, the fixed plate is nothing but your back plate, and the movable plate is the diaphragm, and it is connected to the battery. Both the diaphragm and your back plate is connected to battery in order to measure, which produces the electrical potential between them. And when sound wave exit the diaphragm, that is, when sound is given to the diaphragm, that creates a force, and the distance between the diaphragm and backplate changes, and the capacitance in turn will change the value of capacitance, and this capacitance change will produce the voltage change, which is sent to the preamplifier. This is what the operation that actually takes place in a microphone. And I like to explain this capacitive microphone with the help of a video. And here is the video that shows the working of your capacitive microphone. So we have this is the construction of your capacitive microphone. That is, it has a diaphragm, and this is the static back plate, and this is the movable diaphragm. Generally, we know the formula for the capacitance of parallel plate capacitor. It is given by the equation C is equals to epsilon naught A divided by D. So from this we can understand it is directly proportional to A and inversely proportional to D, that is area and distance. So by variation of area and distance, the capacitance can be varied. This is what the principle used in this capacitive microphone. So when we speak, the voice will make the diaphragm to move, and it reduces the distance as well as the area between that. This result in change in capacitance, which is measured using the AC bridge. So we have seen the operation of capacitive microphone with the help of the video. And some of the points regarding your capacitor microphone is it is expensive, but it is going to be the accurate instrument, and the frequency range will be up to 50 kilohertz and sensitivity will be up to 50 decibels. The applications are, it is used in mixing vocals, acoustic guitar, orchestral instruments, saxophones, and percussion and sound effects. These are the areas in which your capacitor microphones are being used. And the next topic is a piezoelectric transducer, and we all have heard this word piezoelectric transistor. It is very popular for creating electrical energy with the help of force. That is, the electric potential appears across the surface of the crystal if the dimension of the crystal is changed by the application of mechanical force. That is, we are going to place a crystal in between two electrodes, in which the upper electrode will be having a diaphragm in which the force is being applied, and that force is multiplied with the help of some additional devices and given to the crystal. This in turn will change the area or thickness of crystal, which in which it is going to, this change in crystal dimension or deformation of this crystal is going to produce some potential. That potential is nothing but the electric potential, and it is being measured by means of some of the electrical quantities. That is what it is being shared here. So potential is produced by the displacement of charges, that is displacement of charges from the crystal, and this effect is reversible also. That is, by varying the potential applied to the proper axis of crystal, it will change the dimension of the crystal by deforming it. That is, there will be a deforming, that is, there will be a change in the dimension of crystal, and this phenomenon is known as piezoelectric effect. That is, the change in dimension of the crystal by the external mechanical force applied over it will cause the change in dimension, and this effect is known as piezoelectric effect. The word piezo means, it is actually a Greek word which means force or pressure. That is the meaning of the word piezo. That means your pressure or force is converted into electrical energy with the help of transducer. That is what the meaning of your equipment. And the elements exhibiting piezoelectric qualities are called as electroresistive element. The elements which can produce piezoelectric qualities are known as electroresistive element. I like to explain this piezoelectric transducer also with the help of a video. And so in general, a piezoelectric transducer, which is going to convert physical quantity into electrical quantity with the help of the piezoelectric effect. And here are the materials which are used for the piezoelectric generation, that is your rochelle salt, quartz, and tourmaline. And out of this crystals, your quartz is most predominantly used crystal. Why? Because it has high stability nature. It will be stable at any condition. And this quartz crystal will be cutted into a rectangular form in order to place in between the electrode plates. So it is between placed between the diaphragm and a base. This base, and electrodes are fitted to the both parts of your crystal in order to measure the generated voltage. So we are going to apply a force over the diaphragm of the diaphragm. Through this, the force is being applied to the crystal. The force distributed to the crystal through the diaphragm, and that is what it has been happening here. So if any physical force or stress is applied to the crystal deforms and the changes are formed in the crystal surfaces. So this change in deformation occur in the crystal will be producing the generated voltage. Due to this deformation, the electrical charges is developed on the faces of crystal. So here are the electrical charges that is being formed on the faces of crystal. This voltage generated will be measured through these electrodes with the help of some meter. So the generated voltage will be having the formula, that is output voltage is equals to Q divided by C. We'll see the explanation of this formula very soon. So the materials used for piezoelectric transducers are your salt, ammonium dihydrogen phosphate, that is ADP we call it as, and quartz. This is what the actual material which supports to create more amount of energy with the help of piezoelectric effect. And ceramics also being used with barium titanate, dipotassium tartrate, and potassium dihydrogen phosphate, and lithium sulfate. These are the materials used for this piezoelectric transducer. And this piezoelectric effect can be made to be respond to mechanical deformation of material in different modes. As I said, there will be a change in, that is a change in the thickness, or it can be a transverse expression, or the thickness shear also may cause a piezoelectric effect, and phase shear also cause piezoelectric effect. These are the modes of mechanical deformation that can occur. And this is actually the diagram of a piezoelectric transducer. As I said earlier, it has an upper diaphragm, which is where pressure is being applied, and here is a force summing member. That is, it will increase the pressure to the your crystal. This is what the actually crystal, the quartz crystal, and this is the base, and these are the two electrodes where it been output voltages is measured, and this is what the actual diagram of your piezoelectric transducer. And this convert mechanical motion into electrical motion. We know the formula E0 is equals to Q by C, and this Q is equals to, it is the product of force into your applied force into crystal charge sensitivity. That is what D denotes your sensitivity. So product of sensitivity as well as force will be given with the value of Q, and this force causes changes in the thickness of crystal. That is, the change in thickness is denoted as del T. This T is nothing but thickness. So force is equals to A into E divided by T into del T. That is, your A is nothing but area of crystal, E is Young's modulus, and T is thickness of the crystal material. And the charge at electrode gives rise to the output voltage. So your formula E0 is equals to Q divided by P. I am going to substitute the value for your Cp and Q. We have found the value of Q, where Cp is nothing but the capacitance between two dielectric plates, and it is given by epsilon naught A divided by T. Substituting these two values, I am rewriting the equation. It has D into T divided by epsilon naught into F divided by A, force into area. And this force by area is nothing but pressure. So ratio between force and area will be given by pressure. So this value F by A can be replaced by P. I am replacing F by A with the help of P in this equation of output voltage. And one more thing, voltage sensitivity of the crystal is equals to the ratio between your sensitivity to the permittivity. That is epsilon naught. So I am replacing this D divided by epsilon naught with the help of G. So your output voltage equation will become E0 is equals to G into, that is, voltage sensitivity of crystal into your thickness of crystal into your pressure. That is what actually G means. That is voltage sensitivity G, and the T is thickness, P is pressure. So above expression, we can rewrite this equation in order to find the voltage sensitivity also. So G is equals to output voltage divided by thickness into pressure. This is the final equation for your piezoelectric transducer in terms of output voltage and voltage sensitivity. And coming to the equivalent circuit of piezoelectric transducer, here is the quartz crystal, here is the capacitance, and this is the leakage resistance. Q is charge generator, where charge is being generated, and it is nothing but the product of your sensitivity as well as force applied, and Cp is capacitance, Rp is leakage resistance, and this is the equivalent circuit of your piezoelectric transducer. So output voltage is nothing but it is given to the capacitor as well as the leakage resistance connected in parallel to the capacitor. So output voltage is equals to Q divided by Cp, that is charge generated divided by your capacitance will give the output voltage of your transducer, that is piezoelectric transducer. And advantages of piezoelectric transducer: it is small in size, lightweight, rugged construction, it is a self-generating type, that is active type of transducer. It has very high frequency response, that is 1 Hz to 20 kHz, and outputs are quite large for your piezoelectric transducer. And disadvantage of piezoelectric transducer, or your output voltage is affected by temperature variation in the crystal, and it also can be used only for your dynamic measurement. Those are the disadvantages of your piezoelectric transducer. Coming to application, it is mainly used to measure the force, pressure, etc., and employed for high frequency accelerometer. And these are some of the applications which used because of its rugged condition, that is ballistics, rocket motors, etc. And these are the